Thanks for taking the time to watch this video. I wanted to briefly show how we can use linear referencing within GIS to solve a question that was recently posed to me. So we have this riverine feature, and I was provided with two data sets, a dataset A and a dataset B. Accompanying these two data sets was a document explaining the sample methodology that was supposed to be employed for these data. The problem here is that really neither one of these data sets are actually 100% correct. They both have the same number of data points. The data points are named the same. But the real problem here is that these data points should be distributed along this route at very specific distances, and those distances are listed here. I went back and read the sample design and recreated this table, which with this point being a starting point, zero distance. This particular sample starts at 0 feet, and then one route starts sampling northward at increments listed here. The second route starts sampling at incremental distances which proceed through the rest of the data set. Okay, so we have two. I'm going to turn off the imagery here just for the example's sake, and so we have actually two routes here. We have a route that proceeds northward in a positive distance, and we have a route that proceeds southward in a positive distance. And then we have these two different data sets. The specific question was provide a metric or some way to say which one is more correct. So I did this using linear referencing and using routes. So routes are a special sort of geometric construct within the ESRI software that allows you to take tabular data and given a route identifier, again two routes, we have route 1, we have route 2, provide the distances along that route at which those points should be. It's referred to as an event. This could be any linear feature. It could be stop signs. It could be lengths of road at which the speed changes. What can be measured along a route? I mean, it can be time. It can be distance. It's just it's a very useful modeling construct. So the example here is distance for sampling points along this riverine feature. So again, I was able to just type in a data table and say, okay, here's the distances that it actually should be, and we have these values. All of these samples occur at the distances specified in the sample design. So the question then becomes, well, okay, that's what they should be. How do we know how correct, which data set, A or B, which one more closely adheres to the sample design? So using some analysis tools within the toolbox, we're able to actually create another table that will provide you the distances at which each one of these each one of these samples occur along each route. And again, keep in mind, these data sets don't agree at all. So using the analysis tool to provide me with those values, we came up with what's essentially a magnitude of error. Magnitude of error here is defined as such. So for dataset A and dataset B, this MES, this measure field, is the distance along each corresponding route at which the sample was actually taken. We know based on the sample ID what that distance should have been. So for each sample, I just took the absolute difference between what it should have been and what it actually was for data sets A and data sets B, and then really just simply summed those up to come up with some sort of metric to describe the error. So in this case, you can see that we have an absolute error for data set A of about 19,000, and for data set B it's about 24,000. So I was able to go back to the project manager and say, okay, your data set A has less error in it than data set B. So just a real quick, elegant way to show how to use GIS to answer what could be, some pretty complex spatial analyses if you had to do them any other way. Thanks for your time.